Welcome back to educator.com. For the next lesson, we're going to go over some scale drawings. So a scale drawing is an enlarged or reduced drawing that is similar to the actual object or place. So you're basically going to compare two things: the actual object or place and the drawing. So it could be something that's enlarged or it can be something that's reduced. Now we just went over similar figures, right? So it's the same concept where you're going to compare something huge and something small, or vice versa, something small with something big. So again, these two things are going to be similar, meaning they're going to have the same shape but just different size. And the scale is the ratio of the two, okay? A lot of times for scale drawing, we use maps, okay? So a map is one of the main examples of a scale drawing. If you have a map of the city that you live in, then that would be drawn to scale, meaning for every inch or so on the map is going to represent however many miles in real life, like the actual place, right? So that is one example of a scale drawing. If you have, let's say, a person and you draw a picture of that person, but you draw it to scale, meaning you're going to draw that person same size, but just on paper, then that will also be a scale drawing because that drawing is going to represent the actual person or object. Okay? So, for example, if I have a map of, go back to the map example, two cities. So let's say this is city A. That's one city, and here's another city B. Now, this map is going to represent the actual place, city A and city B. So here, if we say that from here to here on the map, let's say this is 2 inches, okay, apart. Well, we know that in actuality, city A is not 2 inches away from city B, right? But on the map, if this represents 1 inch, this is also 1 inch. If I say that 1 inch on the map represents 10 miles in real life, well then, the ratio, the scale, is going to be 1 inch on the map to 10 miles in real life. Okay? So it's going to be the ratio between the drawing and the actual place. Okay? And then you're going to use that to find, let's say, I ask, how far away is city A from city B? Well, on the map, since it's 2 inches, how will I know how far away it actually is in real life? So, if this is a ratio, I can turn this into a fraction, right? So 1 over 10, okay, 1 to 10, that's the ratio. And then I'm going to create a proportion. So then, 2 inches to, okay, x. That's what we were looking for, right? So if 1 over 10 equals 2 over x, well then what does x equal? Okay, so you can either make this using this equivalent fraction, meaning turn this into the same fraction as 1 over 10 to find x. Or remember, we can use cross products. We can multiply this way, 1 times x equal to 2 times 20. So if we multiply across this way and use cross products, then 1 times x is 1x equals 2 times 10 is 20. Well, 1x is the same thing as x, right? So we know that x is 20. Okay, so 20 miles. That means city A and city B, they're actually 20 miles apart from each other. Okay? So let's go through some examples. The first example is the map. Okay, on the map it's 1 inch 1 inch represents 50 miles in real life. Okay, so the ratio is 1 inch to 50 miles. Now, if I want to turn this into a word ratio, remember I could say that this is the map, and then I can say that this is the place or actual. Okay, so this would be like the word ratio. Okay, your word ratio is, in words, the ratio of what's going to go on top and what's going to go on the bottom. So again, the ratio is 1 to 50. And this next part, if it is 100 miles between two cities, how many inches is it apart on the map? Well, the 100 miles. Okay, so then is that going to go on the top or the bottom of this next ratio? Remember, you have to keep the ratio according to the word ratio, right? So it's actually 100 miles. So then that would be on the bottom because that's the actual place. So 100 goes on the bottom. And then the map, how many inches is it apart on the map? Well, the map number is going to go on the top, and that's what we're looking for. So that's, you can call that x. Now, we can solve this. So if we're going to use cross products, so 50 times x is 50x, remember number times letter, you just put them together like that, equals 1 times 100 is 100. Then here, remember to solve for x, 50 times x equals 100. So 50 times what equals 100? I know that x is 2 because 50 times 2 is 100. So that is inches, right? So x is 2 inches. So on the map, it's 2 inches apart. Okay. The next example. The scale of a drawing of King Kong is 1 inch to 3 feet. If King Kong is 54 feet tall, how tall is he in the drawing? So again, we have this ratio. So we're going to say drawing of King Kong over the actual height of King Kong. Right? So this is our word ratio. This is what we're going to base it on. The drawing is 1 inch over 3 feet. Now you don't have to put, these here because we're not going to use that to solve, right? So if you want, you can just put 1 over 3. That's fine. Equals, King Kong is actually 54 feet tall, right? So that's going to go on the bottom because that's the actual. So 54 feet. How tall is he in the drawing? That is the top number, so that's x. That's what we're looking for. So again, I can use this cross products. 1 times 54 is 54 equals 3 times x, 3 times x. And you can just write that as 3x, okay, as long as you know that that represents 3 times x. Now to solve for x, remember if I want to get rid of this, isolate the variable, get rid of the 3 by dividing, right? So I can divide this by 3, and then I can divide this by 3. So here, to do 54, divide it by 3. Okay, put 54, the top number, inside. 3 goes into 5 one time. This is 3. Subtract it, you get 2. Bring down the 4. 3 goes into 24 8 times. So x is 18. That means 3 times 18 is 54, right? And since that's the top number, that's the drawing number, I know that's in inches. So King Kong is 18 inches tall in the drawing. Okay. And the third example, a toy car is made to scale with the actual car. If the ratio of the car to the toy is 15 inches to 0.5 millimeters, and the toy is 6 millimeters long, what would be the length of the actual car? So the ratio of the car to the toy. So that means my word ratio is going to be car over the toy. Okay? So the car to the toy is 15 inches to 0.5 millimeters. And then again, I'm going to create a proportion. The toy is 6 millimeters. So the toy, that's the toy number. I'm going to put that on the bottom. What would be the length of the actual car? So that's going to go on the top, X. Okay. Now again, I'm going to cross multiply. So here 0.5 times x is 0.5 times x, or just 0.5x, equals 15 times 6. So we're going to have to solve that out. 15 times 6 says 0. 6 times 1 is 6, plus 3 is 9. So this becomes 90. Now again, I want to know what I have to multiply to 0.5 or 0.5 to give me 90. So then I would have to divide 0.5. If I make this into a fraction, this is the same thing as divide, right? 0.5. So again, this is 90 divided by 0.5. I'm going to do that right here. 90 divided by 0.5. Okay, make sure that this top number is inside the house, or inside this, okay? Now, to divide this, if you have a decimal on the outside, remember you have to move it to the end. Okay, I moved it one space. That means from here, this end of the number, since I don't see a decimal, it's always at the end, I have to move this number one space. Well, then I have to fill this space with something, and that will be 0. This is my new decimal point right here. I'm going to bring that up. So then I have 3 spaces on top right here. Okay, so then now I can divide. 0, 5 is the same thing as 5, right? So 5 goes into 9 one time. This is 5. Subtract it. I get 4. Bring down the 0. 5 goes into 40 8 times. Okay, that becomes 40. If I subtract it, I get 0. Then I have to bring down this 0. 5 goes into 0, well, 0 times. And that's just 0 and 0, right? Okay, so then my answer becomes 180. X equals 180. So 0.5 times x equals 90. That means 0.5 times 180 equals 90. So again, my car then, because that's the top number, my x, right? That represents the car length, and that is going to be in inches. Okay. So my car is 180 inches long. Okay, well, that's it for this lesson. Thank you for watching educator.com.